Good morning. I'm meteorologist Ross Elt. This is Getting Schooled. We'll give it a few seconds here for some of those folks still coming in at this point. If you are watching us from the area somewhere, let us know. Let us know what town it is. If it's somewhere across the country, that's fine too. Let us know where you're checking in from today. So we're going to talk all about extreme heat, summer heat, and then I've got some extras in there too. I've been talking about all week long. If you've got something specific you want to talk about, you can ask that question for today, or we're certainly going to get to a couple topics. We had somebody wanting to know more about ice ages, so we've got some information about that. Of course, the summer heat that we're talking about, and also we are talking all about how tornadoes form. I think that is the most common question that we have gotten along the way, and it's been 9 weeks now, essentially, since we've talked about it, so we'll walk through that as well coming up for today. But any weather question you have, we'll get to those at the end here for us. Let's talk about extreme heat, summer heat. That's really the one big weather topic we have not talked about over the last 9 weeks here for us. Looking at some of the historic heat that we've had as we start to go into the summer season, it's pretty interesting. Let's go through it. 1934 was the hottest Ohio summer day that we had. Temperatures were soaring here across the region. Those temperatures were well into the hottest summer heat wave that we had. So temperatures there were well into the hundreds, and it was the worst of the Dust Bowl era that we had in 1934. 1936, still in the Dust Bowl era. We talked about this, I think it was just last week at this time we talked about it, but that was Toledo's been to 105 degrees a couple times, but this one particular day, we got up to 105, 111 degrees in Paulding. 1953, we had our worst September heat wave on record. 1988, we were in the middle of an extreme drought. It also got up to 104 degrees. 1995, I remember this one as a kid. It was the historic Chicago heat wave, but it didn't just hit Chicago, it hit the entire Great Lakes area. It wasn't just the extreme heat, it had extreme humidity, and it was the highest heat index on record at 122 degrees. And then 2012, we had a drought and 103-degree temperature reading that year. That was a pretty bad drought, although not nearly as bad as 1988. So that was some of the worst heat that we've had here on the record books. This is pretty interesting, too. Over the last several years, I don't have last year included with this, but 2018, 2017, going all the way back to 2013, we've had an interesting scenario to where our hottest day of the year, which you typically expect in mid to late July or early August. That's usually our hottest time of the year. It's been anything but as of late. The last 3 years in a row, it's been early in the summer season. Actually, it's technically been during spring, May 28th, June 13th, and June 11th. The 3 years after that, September. And September has been very hot for about the last decade, it seems like. So September 7th, September 5th, and September 10th, we had our hottest day of the year, which was pretty remarkable here for us. Let's go ahead and take a look at something else that we'll start showing a lot more of coming up in the days and weeks ahead. It's our comfort index, and this is all based on the dew point. And so any time that we talk about the humidity, we have two numbers to look at. There's humidity, which is in a percentage form. That's relative humidity. And what that means is that what percentage of the air that could be saturated is saturated. And so if it's 100%, that means 100% of the air that could be saturated is, but the higher the temperature goes, the more moisture we can have in the air. And so once you start getting to temperatures that are summer-like, there can be a ton of moisture in the air. So all of a sudden, 80% humidity doesn't feel the same as, say, 70 degrees is what it does at 80 degrees. And so we look at the dew point temperature, and the dew point is the temperature that you would need for you to get dew to form, which brings you into complete saturation. So that's also a measure of how much moisture is in the air, how humid it is. And our humid day that we had last week, I think it was the first time we really had a humid day. We had a humidity with a dew point a little over 60 degrees. Well, you get up to 70, and that's tropical. 75 is oppressive. If you get a little bit higher than that, you get up to around 80, and now you're talking about records that we have. I do want to take this time to let everybody know the difference in that temperature, though, which you could have, say, if you're walking around on the pavement, walking around in the summer heat, or being inside of a car. All the time we talk about not to play around in a hot car in the middle of the summer that's enclosed. Certainly it can be a really bad spot here for a lot of heat. So if the temperature outside is 99 degrees, 10 minutes inside of a car, the temperature goes to 119. Just in a matter of 20 minutes, it's 129. 30 minutes, 134. Now we're getting to the point where you can start to bake stuff inside that car. And 60 minutes, 145 degrees. So you're starting to get up to not necessarily baking temperatures that you would have in the oven, but you can start to actually get to a point where you can actually cook things when you finally get to that high with the temperature. Not exactly a good thing if you're inside that car as it gets really, really hot outside. So that's the difference between the outside temperature and what it can be inside of a car. Keep in mind, the temperature reading outside is in the shade, not in the sunshine. So in the sunshine, it always feels hotter than that. Heat dangers as we go into the hot part of the season. There's heat exhaustion and there's also heat stroke. Heat stroke is the red one here that's kind of underneath the camera that I've got. You've got heat exhaustion if you start to feel faint or dizzy, a lot of sweating, cool and pale and calming skin. This is usually a point where you know you need water, you need to get inside, or else you could end up having some major problems. If you start getting a throbbing headache, no sweating, red, hot, dry skin, that's even more serious, which could be heat stroke at that point. So there are some real dangers of the heat, not necessarily just being out with hot temperatures, but being out in hot temperatures and maybe playing too much or exercising too much and not drinking enough water at the same time. So these are some of the things to kind of take a look at if you start to have some of these symptoms. Drinking lots of water, getting in the AC, at the very least, is something that you should do. That's what I've got when it comes to hot weather. Now I want to hit the two big topics here that I've had questions about. One, how does a tornado form? And then we'll talk about ice ages here, and then I'll leave it up to any questions that we've got coming in. But how does a tornado form? Well, it ends up coming with different winds coming at different directions that kind of help those thunderstorms evolve into a tornado. The thing that you have to remember, though, about any type of weather event we have, and tornadoes included, you have to have the right ingredients coming together at the right time to finally get that weather event. In the case of a tornado developing, you have to have a thunderstorm first. You can't get a tornado if you don't have a thunderstorm that's going to help produce that tornado. So you got to have the instability, the lift, the moisture, that type of thing to get that thunderstorm actually to grow into the atmosphere. But then after that, what you need is the winds to be the right direction, the right speed with height. And the big thing here is having stronger winds above us, above our heads, than what we've got at the bottom of the atmosphere. Because at that point, what's going to happen is that thunderstorm develops and it grows into the sky. It's going to tilt over just a little bit. And that's important because now the rain that falls from that storm is going to fall in one part of the storm, and all the warm, humid air that's fueling that storm, it's like the gasoline for our thunderstorm, is going to keep going. So the warm and humid air that's going into the storm, it's going to come in a different part. The rain's going to end up falling in a different part of the storm. So those winds at different directions, stronger directions aloft versus the bottom of the atmosphere is very, very important. And that also does another thing too, is that it begins to spin the air up a little bit towards the ground. If you can imagine an invisible tube caught in between those two different winds, it's going to end up rolling that over, okay? And so if you've got different slower directions at the bottom versus the top, it's going to try to tilt and roll that over. Now, that's not a tornado. That's just the wind circulating and in a circulation here, but it's in a horizontal form. But as a thunderstorm develops, it produces these strong updrafts, and that's what helps fuel the storm, is that air goes straight up into the sky. And if that interacts with that twisting column of air that's already there, now it can start to do some things that can make the thunderstorm pretty interesting here. It can actually take that thunderstorm updraft, it can rotate that column of air and turn it into the vertical form. And once that ends up happening, the whole thunderstorm can slowly begin to rotate. And after that slow rotation ends up forming, we call this a mesocyclone or a supercell tornado, or supercell thunderstorm rather. The tornado comes next, but it forms a wall cloud. So you get a little lowering with that storm to form first. Still some rotation with that, although it isn't real strong. And then we get a funnel cloud that ends up forming. And if that funnel cloud ends up reaching to the ground, now it's made a complete connection and you've got a full tornado. If it doesn't make a connection with the ground, it's just a funnel cloud. So it's a long process. It usually takes about 30 to 45 minutes to go from, sometimes an hour or longer than that even, to go from a thunderstorm cloud that's building into the sky to an actual tornado. And it does go through this process, but that process is important. It helps forecasters out because with Doppler radar, you can look right into the middle part of that thunderstorm and get an idea of where that rotation is at and how strong it's becoming. And if you can detect that rotation when it's way up into the sky, then you can get an idea that there's a potential for tornado developing if it continues to be that strong. That's how Doppler radar works. Let's go over now. I want to take a look here at the other computer. I had questions about an ice age. What is it like? We've talked a little bit about this already, but I want to go back and also discuss kind of a look at where temperatures have gone, or where we think they've gone, anyways, with the best evidence and data that we've got out there over the last about 400 to 500,000 years. This goes back 450,000 years. And this graph here, this blue line that just kind of crawls along, goes up and goes down, goes up and down, almost looks like a heartbeat monitor or something along those lines. Well, in the periods where it goes up, those are warmer temperatures. And the periods that it goes down, those are colder global temperatures that we've got across the globe. And so let's go to today. Today's clear at the end of this, and you can see where it's what's called an interglacial period, which means warmer weather that we've got across the globe. Now, we're not at the warmest point that we've been in all of recorded history. There have been some points that have been a little bit warmer than where we stand right now, but not by a whole lot. We're at a pretty warm point right now in Earth's history. But if you go back about 14,000 years ago, then we were at the bottom of that temperature graph, and we were in what was called a glacial period. And that extended, you can see we went into it, and it warmed up a little bit, sort of thawed out a bit, and we slipped right back into it, and then we have come up, and temperatures have gotten much warmer ever since. If you go back more than 100,000 years ago, then you get this really warm interglacial period that we had on Earth, which was followed by more glaciers, and this just continues to go up and down. So you've got warm period followed by glaciers, warm period, glaciers, warm period, glaciers, warm period, more glaciers, and now to where we are at this point. And this is all observed off of ice cores that we've got. Let me go back and take a look here. Let me go back, and may remember some of these slides here from just a couple weeks ago, but it does have a lot to do with ice ages altogether. We're talking about 14,000 years ago being in that last ice age. This is an estimate of where glaciers were 18,000 years ago at the top of your screen, and those glaciers coming all the way down to here in Toledo. We had, that's how the Great Lakes were formed. Actually, they weren't formed from just one glacial period, but it's believed that it was from multiple periods like that. But as these glaciers melted, they ended up leading to the Great Lakes. This is a look at modern day, where you got some ice here right over parts of Greenland, and there'll be ice here covered up over the Arctic Ocean too, but in this graphic it doesn't have it. But the United States image here towards the bottom shows how far to the south those glaciers went, which again was right over where we were at. So pretty neat stuff. These glacial periods happen about every 100,000 years, about every 40,000, 100,000 years generally. And the reason why do we go back and forth between these warm periods and cold periods? Well, the Earth itself is kind of like pizza dough in a sense, or bread dough, and that bread dough tends to rise somewhat, and as this happens, it changes the tilt, which makes us colder. So when we end up warming up, the Earth again kind of begins to rise a little bit, just a little bit. It affects the tilt of the Earth. Yesterday, or earlier this week, we talked all about the tilt of the Earth and how that has an impact on our seasons. Well, if it changes the tilt enough, it can actually make us colder, and then usually the reversal happens. So this is a natural phase, natural process that takes place over the course of tens to hundreds of thousands of years for us. One other thing I'm going to bring up here, because it may answer some questions coming up, it may not, but regardless, let me go back here. Coming up here on Thursday, Jay, this will be later tomorrow, Jay at 11 o'clock is going to deliver the summer forecast, the summer outlook. And while I'm not going to give all that away right now, I'll give you a little preview of what I'll be talking about coming up for tomorrow, which is how we got to this point. So we're getting close now to the summer season. We're starting to talk about some summer warmth and humidity back in the 7-day forecast. It's only a matter of time before that ends up happening here for us. I want to go over and show you where we were at for the winter season. And you're going to see here, go over to that graphic again. And let's see here. You can see that going all through, and then it kind of disappears. So I should have added a pause there. This is a good thing. This is a good thing that I'm going through this now. That way we get everything right before we actually show it on air for tomorrow. But this winter setup, it was really, really cold in the northern part of the hemisphere. It was really, really warm just about everywhere else. So over Alaska, northern Canada, the North Pole, extreme winter setup. Everybody else was quite warm. We did talk about this not long ago. It's because the polar vortex was so strong that all of those winds were circulating very strongly around it. The jet stream did not move much over the winter, and as a result, the cold air got colder and colder and colder, but it never changed the pattern during the winter season. Now, what's happened during the spring season is all of a sudden that polar vortex has become weaker, and now the jet stream fluctuates a lot more, and the cold air is wobbling its way right out of the North Pole. And that is part of the reason why. Also, there's a big ridge out to the west. Alaska went from being really frigid over the wintertime to becoming incredibly warm during the springtime. Warm air went all the way up towards the North Pole and ends up pushing that cold air right out of the North Pole. And wouldn't you know it, everything was lined up perfectly for that cold air to come in. So while March was fairly warm, this whole pattern flipped around in April, and it has been generally locked into this pattern during the month of May. We would have been out of this pattern already 5 days ago if it wasn't for a tropical storm developing. Tropical Storm Arthur off towards the east coast, which slowed the progress of all this heat moving in. So this warmth has been wanting to move in for the last 5 days, but this whole weather pattern has basically come down to a stop, and now it's beginning to pick up again, and this warmth will get here starting for this weekend. So the big question is will this pattern, now that it's beginning to flip over, is that a sign of where we're going for the summer season? Jay will have that answer at 11 o'clock, and if that's a little too late for you, we'll have more of those answers coming up on Friday. But anyways, we are about ready to break out of this pattern that we've been in, which has been so cool here for us over the last few weeks. So that's what I've got to talk about today. Now it's all the questions that you have weather-wise on anything that we've talked about over the last 9 weeks. Let me go over and see what we've got right now with some of those questions so far. Let's see here. Derek asking, is our weather trying to catch up with the atmosphere due to chemtrails? Chemtrails that is a conspiracy theory when it comes to those. Usually you got airplanes, they have contrails. You can see the steam that comes out of them. That's quite warm when you're 30,000 feet above the ground. And just like that, as you have a little bit of warmth and humidity in that cold of an environment, it immediately leads to basically what's called a cirrus cloud. If the atmosphere is humid enough and you lead to those trails that go across the sky, there are many that believe that that's something else and that can cause harm and so forth and do a lot of different things towards our weather. So I'm not going to get into all of that, but when it comes to the trails that you see from the airplanes, there's really no issues with that when it comes to the weather. When is a good day to cut the grass? Sherry asking this. That's a good question. Not today because the grass is still so wet. Obviously, in some cases, maybe there's still water standing into the front lawn or the back lawn. As we get in over the next couple of days, the lawns will gradually begin to dry out. So you might be able to get out there later tomorrow or even on Friday. But I think Saturday's probably your best bet, quite honestly, even early on Sunday before any more rain begins to develop. It'll be warmer. There'll be more sunshine. By that point, things should finally start to dry out. So. And I'm going to have to get out there and do the same thing and cut my grass as well. Let's see. Conley asking, just east of Findlay, Ohio, how does the 30-day forecast look? Drier, I hope. So right now, obviously, it's been very wet as of late. There are still small rain chances in the 7-day forecast where there might be some sprinkles or an isolated shower, say later tomorrow or on Friday. Then we're going to get into this pattern that's typical of summer, at least for several days as we head into late weekend, Sunday, Monday, and Tuesday of next week. And that you get that warmth, you get the humidity, and there'll probably be some scattered thunderstorms around the area. That doesn't mean that everybody's going to get the rain. That doesn't mean it's going to rain all day like what we've had, but some of those scattered thunderstorms will be around the area. Now, if you look at the average and start to expand it out, it looks like as if where rainfall could be around average, maybe a little above average as we head into early next week, but it doesn't look to be as significant as what we had. If you go up beyond that, into the final days of May, into the first week of June, if anything, it looks like the precipitation would be below average. It would actually go the other direction as you head that far out. And then if you look at the 30 days as a whole, you don't see a huge opportunity for a lot of rain or a lot of dry weather. So essentially it looks like everything's going to try to balance out somewhat. If you got 5 inches of rain over the last few days, you're probably still going to have above average rain if you look at everything all together. But when it comes to the weather that's upcoming, it looks like a rainfall amount will probably be around average or above average as we head into early next week, and then it's probably going to go below average heading into early June. So I don't think we're locking into a pattern like what we've had over the last few days where it's cold, cloudy, gloomy, windy, and rainy. I don't think that's going to be our summer. I don't think that's going to be our late spring. I really do believe that we've got some great weather that is on the horizon, some warmer conditions too. Let's see. Mohammed asking, what was the strongest tornado? So the strongest tornado, there are different ways, I guess, of measuring a tornado. You can measure it off of the wind speed or the estimated wind speed. There have been outbreaks in Oklahoma, around the Moore, Oklahoma area that with Doppler radar this is above the ground, keep in mind, but it was, at least by Doppler radar estimates, that you had tornadoes with right around 300 mile per hour winds. So some of these big outbreaks that have happened, one was back in 1999. There's been some others since then. That a couple of these tornadoes really stand out. To me, I think one of the most powerful tornadoes that I've ever witnessed would have been more recent. And I can't remember the date off the top of my head, but it was about 5 years ago or so. It was the El Reno tornado. If you were to take a look and Google El Reno tornado in Oklahoma is where that was at, you'll find tons of information about it. But it was a very bizarre and powerful tornado. It was multi-vortex, and it rapidly expanded from about a mile to 2.5 miles wide. And as far as I know, that is the record for the widest tornado on the record books. So really impressive stuff. Matthew asking, anything going to hit Hillsdale County? If you're asking over the next few days, not much, if anything. There's only a 20% chance tomorrow or on Friday of an isolated shower, but that is pretty much it. Muhammad also asking, can tornadoes develop in any season? Absolutely, and they do. In fact, in the deep south, they get a lot of tornadoes in late winter and early spring. Our tornado season is usually late spring going into the summer season. So the farther north you go, the later into the spring season that we have tornadoes. But even in the fall, there are tornadoes that typically happen. So obviously they don't happen nearly as much in December and January, but they do occur sometimes. Even in Florida, during El Nino years, they typically have a little more severe weather there. James saying, why y'all making it rain so much? Man, I wish we could turn off the faucet and turn the rain off. If we had that ability, we would certainly do it. I'm tired of it too. Terry saying, explain a white squall. I'm going to assume, Terry, that you mean a snow squall. A snow squall is a combination of an intense burst of snow, very heavy snow, but it doesn't last all that long. But it also comes along with quite a bit of wind when it does move in. So the problem with snow squalls is that you can be driving down the road and everything's totally fine. You may see some dark clouds approaching, almost like a thunderstorm. And then you go into the snow squall, and just like that, it goes from blinding whiteout, heavy snow, intense winds, and you can't see anything. And 5 minutes later, you may come right back out of it. Well, the problem is it reduces visibility so quick that it can lead to a lot of traffic accidents. And because of that, the National Weather Service has just come up with a brand new warning, kind of like a severe thunderstorm warning, but it's for snow, and it's a snow squall warning that they'll issue this for. To this point, unless I'm missing something, we have not had a snow squall warning for any area, any county in our viewing area. They just came up with this warning. We really didn't have much of a winter last year, but if you end up seeing a snow squall warning down the road, that's what it is. It's a big burst of strong winds and snow occurring here at the same time. Todd saying, why does it seem like severe storms approach Lucas County and split and go north and south around us? Todd, there There's a couple different things going on here with this. One is that the lake sometimes does have an impact. Now, it can have an impact on a lot of different things. We talked several weeks ago about lake breezes that set up. So the cool air comes off of Lake Erie. You've got that warmer air that usually leads up to it. That gives you a boundary there. Sometimes that boundary can be the focus for where storms fire up. It can be the focus even for a tornado occasionally if all the other ingredients come together. But it can be the focus of thunderstorms. Sometimes the cool air from Lake Erie can help storms stabilize, which would allow them to weaken and maybe go north or south. Many times, though, storms do this without Lake Erie in mind at all. That's just what storms do. They begin to grow. A lot of times they may break up. All storms are going to die at some points. Why storms would take a turn to the right or to the left, a lot of times will have to do with the winds that are impacting it and where the warm and humid air is. So even though the Lake Erie has an impact, every single location that I've worked in, which includes the state of Indiana, Ohio, West Virginia, we had counties in Virginia, and also Arkansas, and we had counties in Oklahoma. Over the last 15 years, I've had people ask me that question for every single place that I have worked at. And it's a lot of times just the nature of the thunderstorms that do develop. The other thing, too, is that it's also about perception. Sometimes if you're focused on one location, you're just kind of focused on what happens there, but maybe you don't notice the storm splitting around, say, Adrian, or sometimes around Findlay or something like that, where storms kind of evolve and shift and move and split and do a lot of different funny things that is pretty common actually altogether. Michael asking, how hot and humid is it going to get this summer? I'll let Jay kind of dive into that with his summer forecast a little bit more when he gets to that point. But overall, I'll put it this way. I don't see any reasons why we would go into a drought and have an exceptionally hot and dry summer. I don't see any reasons why we would have an exceptionally wet and cold summer. Overall, I think you're going to see something that more or less kind of resembles a typical summer, whether that's a little hotter, a little colder, a little wetter, a little drier than normal. I think it's going to be relatively close. I don't think we're going to deviate too far off of what we typically see. Brian asking, any bad storms next week? Right now, I don't see that in the forecast. Now, the thing with severe weather is that we know that we have thunderstorms in the forecast right now. I don't see that going away from the forecast totally with that heat and humidity. If other ingredients all of a sudden show up on the weather map, say a couple days from now, it could change the severe weather forecast. So right now, it doesn't look like that severe weather would be a huge threat, but honestly, a lot of the time, those severe weather threats become a little more obvious when you're about 2 to 3 days away. So it's a little farther out. Yeah, the first chance of actual thunderstorms would be Sunday. Monday and Tuesday, probably a little better shot next week. So we'll have to wait and see on that. Let's see. Can a hurricane rip off roof tiles? Courtney asking that. Absolutely. Yeah, hurricane. In fact, pretty easily, a hurricane can rip off roof tiles. Even a Category 1 hurricane can do that. Let's see. What happens when objects get caught into a tornado? That tornado ends up spinning up that debris, and it's going to land somewhere. It just depends on where. Now, there have been cases where a large tornado has gone through a town in Wisconsin, passed over Lake Michigan, and dropped small debris in Michigan, clear on the other side of the lake. You're talking a significant distance there, 50 miles or so. Now we're talking small objects like checks, paper, that type of thing that can be traced back to Wisconsin. So sometimes this debris can be caught up into the atmosphere for a long time if you've got sufficient winds to keep it up. But eventually it's all going to fall somewhere. Faye asking why all the northeast winds. As of late, we really, up to this point, haven't had a whole lot of northeast winds compared to what we've had over the last 2 years. But now the problem is that we got into a low pressure center here that stayed off towards our south and our west. And because of the circulation around that area of low pressure, it is counterclockwise. And so because of our location and where the center of the low is, it's going to direct the winds right off of the lake. And the northeast wind or northeast wind, an east wind, that's essentially what we've been dealing with. Now, the issue is that is a cutoff low that stalled out and was just spinning around for days. And because of that, I mean, that was our location for that northeast wind. Now we're stuck with those northeast winds, and it's been like that 4 days, and it's going to continue like that for the next couple of days. So while we haven't had a whole lot of days with that lake breeze here this spring, now we're making up for it because we've had day after day after day after day. But it's really because of one unfortunate storm that stalled out and has totally got stuck kind of in place. See, Tiny saying, and we in Finley get more rain next week. Yeah, most likely you'll get some more showers starting Sunday, but this is going to be more hit and miss, typical showers and storms here for us. Daryl saying, can the movie Day After Tomorrow ever happen in real life? Simple answer is no. Not like it's depicted in that movie. There are some scientifically inaccurate things that are taking place in that movie, especially when you're looking at cold air coming down from the atmosphere layers from above, right from the stratosphere, coming all the way down to the ground. If you were to really take the air that's up in the stratosphere and force it down to the ground, that would be a compression, and that would heat the air up. It actually wouldn't cool it like that. It would heat it up quite a bit. So, no, there's a lot of inaccuracies in that movie. It's a fun movie to watch, but from a weather and scientific standpoint, not exactly very accurate. The Perfect Storm is probably the most accurate weather movie that's out there. If you look at Day After Tomorrow, that's not very accurate at all. Twister is a little better, and I love Twister, but it's still not great. The Day After Tomorrow, though, that was based off of a real storm, or I'm sorry, not The Day After Tomorrow. The Perfect Storm, rather, was based off of a real storm in the early 90s that kind of almost like Superstorm Sandy. It ended up combining several different storms with it and turned into this mammoth storm that took on properties of a hurricane, took on properties of just a powerful nor'easter, and did quite a bit of damage. So I think that's it. I'll give it just maybe another 20 or 30 seconds here to see if any other questions come in. But I've had a lot of fun doing these over the last 9 weeks. If you have missed any of them and want to go back and watch them, and we have gone through all kinds of topics here. First week we talked about severe weather. Tornadoes, hail, wind, lightning. Second week, we talked about earth science, volcanoes, earthquakes, and wildfires. Week number 3 was weather technology. And week number 4, that was our forecasting week. So weather technology, radar, satellite, computer models, weather balloons, how to forecast, and then cloud fronts and forecasting. Then we talked about space weather, the aurora, meteors, and eclipses, Great Lakes weather, mountains, monsoons, the polar vortex, blizzards, thunder, snow, ice storms, climate, El Nino, Toledo weather stories, changing seasons, hurricanes, and extreme heat. That's the list of what we've got. All of that can be found on our YouTube page, whether it's now, whether you want to go back and watch 2 weeks from now. Go to YouTube, type in 13ABC, and while you may have to scroll down a little bit, but you'll find all of those Getting Schooled segments, episodes 1 all the way through number 27, which are all of them will be up there. You can also find them on our website and some other places too, but our YouTube page is probably going to be the easiest for you to find all of them in a row. Looks like that's it on the questions. Again, thanks for everybody that's watched, and hopefully you've had some fun with it. Here's the last thing I want to say. If you have a question that you forgot, or maybe you got a weather question that you think of a month from now, find me on Facebook, meteorologist Ross Ellett. That is my 13ABC Facebook page, meteorologist Ross Ellett. Go to that Facebook page and then send me a private message there on that page. That'll be the quickest way. I'll get an alert that message has come in. Ask me the question. Have mom or dad ask me the question. Is not going to bother me at all. You can just say, hey, you're one of Ross's Getting Schooled segment. One of Ross's Getting Schooled students wants to ask a question. Whatever it may be, let me know. So once again, it's been great. Hopefully you guys have a good summer.